start that right now. Yep. So if you don't want to, if something happens to the microphone or if there's anything you want to ask about the course or so when we're not online, wherever it might be, you can type that in there. So it's an extra option for things that can't be said um, in person. You know. So it looks like the stream is up. Excellent. Okay, so let's get started. MEC 330, Programming for Industry 4.0. This week will be the introduction to it. So um, this is sort of the agenda for today, or what we're going to go through. A little bit of a welcoming to the BAS meta. Then we're going to go through the syllabus. We're going to do our COVID update. And then we sort of get into the topic at hand, and we'll start off with an introduction to Industry 4.0, and then we'll move on to an introduction to Python and MicroPython or CircuitPython, which are the two programming languages that we will be primarily focusing on in the course. And then we're moving on to a little bit of practicality and compilers. And then we're going to talk about equipment needs. I'm going to provide some useful sources of information for you guys, and then talk a little bit about a strategy for the quarter. The lecture slides are available on Canvas under week 1. I hope that's published or so. Somebody please let me know if you can't find it or if it appears to be weird. And that's basically what I'm hoping that we'll be able to get through today. Thoughts, questions, comments, or concerns? Excellent. So moving on then. Welcome. So the first cohort. Yep. Yes. Okay. Very good. Thank you. Mute the Twitch stream to get rid of the echo. Don't mute Discord. Do the opposite. Mute the Twitch stream because the Twitch stream is probably going to be 1 to 2 to 3 seconds behind what's on Discord. So we'll use Discord as the primary source. Thank you. I should have pointed that out. It's better to mute the Twitch stream. So see, that's the danger of getting like just comfortable with something, and it's like, oh yeah, that, oh yeah, that. Yeah. So leave the Twitch muted, and we'll use Discord because it's faster. The stream will always be a little bit behind. I can see already now that it's a second or two behind. And I'm going to try to keep that in mind when I'm referencing something on the slide or drawing on the slide as well. That if I'm pausing a little bit is usually to let the stream catch up so that what you hear on Discord is also where my hand or pointer is on the Twitch stream. Also, I will that we are talking about on Discord is not recorded or transmitted onto the Twitch. So you might hear me repeat the question out loud, and that's for you guys so that if you ever go back and look at the YouTube video of the lecture, that there's some context to what the heck is going on, if anything seems weird. So, yes, welcome to the BAS. I think all of you are OGs. It would be very weird if you're not, but basically all of you have gone through the AAST program or the associate level of the mechatronics program into the BAS, which is short for Bachelor of Applied Science. and META, Mechatronics Engineering Technologies and Automation, I believe it stands for, um, which is what we're going to continue on. So what's the difference? Um, I've been trying to figure out a little bit on how to describe what you should expect to how what you could expect as to things being different between what we're about to do now for about 6 quarters or so compared to what you've done in the past. And we're gonna talk more about that, and it's gonna be reflected a little bit differently depending on which course we're currently going through. But a big difference will be that in the associate level, you were focusing a lot on sort of the component or the task at hand. So we talked about a very specific component and how that related to an entire system, or we talked about a particular task that was being done by a larger system. So if we talked about electric motors, like how to diagnose a motor, how to install a motor, how to work with three-phase when we had this kind of component in relationship to this kind of component. How do we set up an LED in a DC circuit so it doesn't blow? Like we always had this system in mind, but we talked about particular components or particular tasks that was being done by the system and how that fits into a system. Now we're going to be moving on to more the entire assembly, so multiple components working together, or the system as such, and how that relates to other systems. So I'm going to assume, or anybody teaching in the BS is going to assume that you understand how components work and how system elements work so that you can exist on sort of an entire system level and then make decisions based upon how that entire system acts in regards to other systems or a series of tasks or sort of the interplay between many tasks. So it's one step higher up on something that you might have heard from the associate level is that we talked about sort of strategic operational and tactical. You're going to have to, on your own, always keep in mind, even if we're talking about components, because that will happen too, we will be talking about components, you have to automatically take into account that this affects things that are on the strategic level, things that spans over time, longer periods of time, expands over multiple departments on that, what part does this have in the chain reaction of events that lead to, entire businesses working and functioning. So a lot sort of higher level where even if we're talking about components, you're going to have to take a lot more into consideration as we go constantly. So it's not going to be, lol, that's not my job. No, you're going to have to think about, if we do this, how does this affect, customers, marketing, different departments, different suppliers. So a lot bigger picture, a lot bigger picture. You'll also have a lot more independence in terms of that. It's going to be less so that in the associate, it was a lot, this week's lab, this week's assignment, I want you to do exactly this, exactly this, exactly this, and this is exactly how I want you to do it. This is exactly how I want you to do it, or this is the outcome that should come from this. Because there were some assignments and some activities that we did that you had a lot of freedom, but the outcome was supposed to be that this works in a very specific way. That now you're going to be released to work with less sort of deterministic outcomes, but at a much higher expectations of due diligence. So you're going to be asked, and again, we're talking about rather than a component level working inside a system, we're not talking about a whole system level. So like, yeah, I changed this, or yes, I decided to go with this, or no, we're not going to do that. and I'm fully aware of all the consequences of this decision, and I can present them to you that by doing this, this is going to happen, this is going to happen. That's a calculated risk. That is an outcome I'm okay with. That is an outcome I'm looking for, and being able to basically specify a lot more on your own. So a lot less repeat after me, but more defend yourself. Defend your statement, defend your decision. And not defend as in that I'm going to be looking to get you, but that is making it's basically more making professional decisions and weighing them and justifying them and bringing to the table that entire argument. That's more what we're going to be trying to do. So not so much. I mean, if you have 120 volts in a 10 amp breaker, it's going to be 1200 watts. That's pretty absolute. Here, instead of having those kinds of problems or opportunities, this is going to be a lot more open, where you're going to have to take that entire chain and package it and present it, rather than it being there's going to be less sort of less digital answers and a lot more open and analog answers. Does that make sense? Excellent. So, and I mean, there's a lot on you guys' shoulder. You now belong to a top 10 mechatronics program in the nation. So, there's a lot of responsibility that comes with that. No. That would be one of those where it's where we're weighing it. So the absolute statement is like you belong to a top 10. We would like to stay there, but no, there is not more than 10 yet. So, um, by default, but yes, those are the type of analysis that we will be making. um, so obviously a lot rides on you guys' shoulders. No, and that's something that is going to be interesting, because so today we're going to be talking about Industry 4.0. It's kind of atrocious actually that it's so rare with mechatronics programs in this country. Europe has well over 150 bachelor degrees in mechatronics and something like over 60 master's programs, pure mechatronics. The United States does not have that, which has led to these courses that you guys will be taking are quite avant-garde. My ambition, because I will be your primary instructor, I think, through your guys' entire journey, will be to try to present the content that you guys are learning as actually tools that are ready to be deployed as soon as you guys learn them or as you're starting to develop them. So I'm trying to stay away because again we're a BAS. That A is very important. The applied is that I want you guys to develop tools, skill sets, and applications that you can immediately put into work in industry, because that's sort of where we're at. We have a lot to catch up on, and we have very little help from industry, very little help from academia, and yeah, I mean we're kind of behind, which is not a popular thing to say. I know I'm not getting very many friends locally or regionally for saying such things, but it's true. So it's something we're going to be working on, is to not be so esoteric and explore things that are untangible. No, we're going to be looking for things that we can immediately put to work. And the course that we're talking about today and also tomorrow are primarily tools to set you guys up to put some of these things in practice. So we're this quarter we're adding to the toolbox to be able to get really good at what we'll be talking about later. So the suggested journey this sort of suggested path that you guys will be taking is if we look at quarter one, we have Math 142, and we have Programming for Industry 4.0, and then Environmental Sustainability in Manufacturing is that our first quarter. So every BAS student will be taking Programming, Environmental Sustainability, and then the Gen Eds are just in there to sort of tag along. Following quarter is Fixtures and Workflow and Industrial IoT, and both of these will rely heavily on things that you learned in programming and environmental sustainability. Environmental sustainability, a lot for thinking about data to information flows, and then programming for working with this information. What's not on here that I've sort of taken for granted that you guys know and are up to speed, but this is something you should be. I'll mention it now so that it doesn't come as a shock for you guys next quarter, is that there's basically 3 tools that are very important, that's going to be very important for you. Systematic thinking, which comes from things like lean, industrial, environmental sustainability, and whatnot. Programming, Python, C++, and then CAD. So CAD and programming are going to be tools for expression, and then lean and environmental sustainability is going to be for method of thinking. So yes, absolutely. So that's something I'll check with. I'll talk to Jason as well, and I believe Claire Campbell is teaching CAD this quarter, so we're going to make sure that they're aware that we're going to swipe some SolidWorks licenses. But so I imagine that some of you, especially the really OGs coming in, you guys, your SolidWorks might have expired, but perhaps the rest of you are also pretty close to like that time period being up. Is that correct? Excellent. Gotcha. So we're going to come up with a way then to distribute new ones for you guys. And also you have access to the classroom and computer lab upstairs in the building. So a kind of a cool thing that's happened is that due to adjuncts and me and Jason, I think I'm going to confirm, I'm not sure, but that we basically have access to the lab more or less 7:30 to 7:30 Monday through Thursday. Gotcha. Okay, so Tuesday, Wednesday, and Thursday we have until 7:30 at night, and then Monday 7:30 till 3:30. So depending on what your main battle station at home is capable of, if your current computer is not super stoked on SolidWorks, will you have access to the ones at the lab. And that goes back a little bit towards that independence that I was talking about as well, is that in previous associate level classes, you sort of had CAD assignments to do CAD, you had program assignments to do programming. The tools that you have here, so after you've done the programming, after you've done IoT, you've already done CAD. I'm going to be expecting you to use these as tools of expression and visualization. So when you're working with fixtures and workflow, I could be perhaps asking you to think of a way to orient springs onto different components with a robot. That would be one of those where you would use CAD, for example, to showcase to me what you had in mind and how you reasoned behind it or so that when you present an idea, you're using SolidWorks as a form of expression to perhaps just to CAD up parts to take pictures in different angles, or coming up with different alternatives where this one is good for that, this one is good for that, this one is good for that, using SolidWorks as a form of expression rather than me asking you, like, for CAD assignment this week, yada, yada, yada. Does that make sense? Excellent. Uh, Develop that a little bit further. Very open. Very, very open. Very, very open. Because that goes back to that A and BAS. Uh, and then I mean, depending on a little bit on what we're working for, but like pulling information from the real world, and also applying, you know, skill, um, to the real world is perfect. That's what that's what we're aiming for in the end result. So the earlier we can do that, the better. And that, I mean, and it stays really within the spirit of these things. So as these courses go on, so when we look then fixtures and workflow in IoT, the second, so every BAS student will take the Programming for Industry 4.0, because like coding is a way to express yourself that is unavoidable. So some of you might have horrific memories of what programming in C++ or the Arduino was like, and some of you might just be indifferent to it, and some of you might have enjoyed it. We're going to really develop that further because being able to express yourself or use coding as a tool is unavoidable. And we need to get over that hurdle. If you feel that you're not comfortable with it, we need to make you comfortable with it. So that's going to be really important this quarter. Um, then fixtures and workflow, we're going to be looking at sort of um, the sort of automation on a process or task level, and how that relates then to other systems. IoT, Industrial Internet of Things, getting used to that. Again, unlocking it as a tool. And then comes the ability to customize this program towards what more finds your fancy or what kind of industry you would like to be in. Because from quarter 3 through quarter 6, there is an elective that you can pick to take your degree in different directions. We currently have 8 electives, and sometime next quarter, halfway through, or perhaps even in the beginning, I'm gonna start having conversations with you guys as to which electives you would like and how you prefer, sort of ranking them, what's of your interest or not, and that will influence how those electives get offered. Because we've got 8 to choose from, and there's 4 slots. And then towards the end, there's a MEC project management, basically a final project, sort of the capstone experience, but it's going to be project based. Where on this picture, it's missing the MEC project management course is actually 7 credits, where 2 of those happens in quarter 5, and 5 of those happens in quarter 6. So those 2 credits of MEC project management will happen in quarter 5, where you set up your project in advance so that when quarter 6 hits, that you basically can focus on doing the project. And there we have some flexibility as well as to applying that to perhaps place of work or places in industry where you would like to end up or are currently at. So, thoughts, questions, comments, or concerns about that? The That's actually you will have some flexibility there. Uh, One or two of you, perhaps, or 2 of you could do it together, or you will be alone. And there's also an opportunity where this has sort of been created that you would take charge of an applied MEC class as from a project management perspective of associate degree students. So you would have a project, they would have to work on your project with you, and you're in charge of them. And they will get an applied MEC grade based upon their performance in your project, and you would get a project management grade based upon the management aspect of it. We're still ironing out those details because it's a little bit ways away. But again, the idea here is to make you guys highly competitive and very lucrative individuals. So we're gonna make sure that we fulfill the outcomes, but at the same time setting you guys up for the highest amount of success. Um, Probably not. Um, there will be four of them, at, at least four. I don't know how many more. Uh, that will be up to the dean to decide. However, we do have some influence on which ones. Also, some you some you can't really you can't take digital twins before um, I can't remember which one is a prerequisite, but like your first elective being digital twins, for example, would not be a good success. So that's why we're going to be talking more about that very early on in quarter two to iron that out. Because I cannot remember how many students have to be signed up for a class for in order for it to run. That decision lies with the dean. Does that answer the question? Have you guys already now the first day? Have you guys had a chance to look at the elective lists? Are there any ones that you guys are particularly curious about? Gotcha. It's published on the webpage, I believe. So if you go to, let's see if I make sure that I'm not lying, cptc.edu, I can throw that into the text chat immediately. If we search for BAS, we only get interior design. What's up with that? Let's search for meta. There it is. Um, so I believe all of these. Oh, look at that. Vayner beat me to it. So there is a link posted now in the text chat that will have all the courses listed. So if you don't recognize them from the flow here that's currently on the stream, that will be an elective. So we have process control, advanced sensors and actuators, AI and data analytics, automation, evaluation and implementation, machine vision, dynamics of machinery and kinematics, robotic integration, simulation, emulation, and digital twins. 1, 2, 3, 4, 5, 6, 7, 8. Yep. No, and all of those, and that's why we'll talk more about it next quarter as well, because all of those might need further, um, you might have questions about it, because all of these are very trendy, very sort of loaded words. So like AI and data analytics, or or digital twins, like that means a lot to different people. It means so, and that's precisely. I'm not ready today to really define down where um, exactly what, because I mean, if we take the AI and data analytics, we will go into an overview, but then there will be paths in there that leads to an application, like in actual applications. And then we're going to be talking about, so I mean, most AIs today are basically just a whole bunch of if statements and variables that overwrite themselves. Um, and that's or machine vision. We can there. It's is it about cameras? Is it about the interpretation of what the camera see? Is it about so that's um, don't have full granularity yet of what 10 weeks looks like for each one of those yet. Um, but for um, let's see what I don't want to say anything that is then going to change later. Um, well, and not so much the guinea pig cohort, but it's going to like we're going to cut through. Part of my French. We're going to cut through a lot of the BS because a lot of these there's basically three types of AI. Like if we talk about artificial intelligence, it's not like unfortunately we're not yet at sort of a Jarvis that you can have a witty banter inside your helmet with some kind of snorky British accent, um, esoteric voice that's going on. But like you can basically have automated decision making that is self-improving and and currently we have three well-established ways for a machine to learn and then to based upon how it's learning then make in the beginning fairly dumb decisions and then better and better and better decisions. So we'll go through that and we'll go through the different styles like um, because I mean when how AI has developed, first we tried logic. And logic AIs are good at some things. Then we tried to basically copy a human brain on how to process information and decision making as similar to a human brain. Uh, that has taken us a little bit further, but they're all both on they're good on their own individual things. And then we'll sit down and we'll take this and we'll turn it into actual tools that you guys can apply, which is why we have to do the programming class first. Because without Python and C++, um, we can't do anything. So, and that's also a bit too soon to say, but you can sort of branch a little bit towards more data analytics or towards AI, depending on where your preference lies. So I will have to follow up with more information on that. But the A and BAS still is going to apply. Um, have you guys heard a joke? Do you know what the definition of an algorithm is? It's basically a piece of code that a programmer is too lazy to explain. Yep. So, um, But yeah, there will be more information as we get closer to making those decisions, and also which ones relate to which ones, because there's a couple of paths, um, depending on which ones of these electives that you take, that will lead you towards more ones and zeros, or more uh, things moving in the real world, or things creating things that will appear in the real world. So next up then, MEC 330 syllabi. So on the canvas is the syllabi under syllabi. There's also a quiz that is due Friday. That quiz will give you 20 free points towards your grade. So please take that, and it's basically, I believe, two questions. One is that you acknowledge that you read and understood the syllabi, and the second question is that you're okay with and aware that I will be calling out whatever name you're using on Discord, so that um, I can sort of, can you repeat that so and so, or so and so, please answer this. So let's look at the syllabi. Let's look at the syllabi. So, and there it pops up on a Twitch stream. So the program, BS Meta, MEC 330, Programming for Industry 4.0, 5 credits, approximately 30 hours of lecture, and approximately 40 hours of lab for a total of 70 hours. My name is Carl. My office hours will be 7 a.m. to 11:30 on Wednesdays and Thursdays, and then 12:30 to 3 p.m. on Thursdays, where I will be at the lab. So let's talk about these office hours, or how labs will work. There will be, depending on the subject, scheduled labs for particular things. Not so much this quarter, because again, you guys are able to operate a lot more independently, considering that we don't have restrictions in terms of equipment that we're using. Future courses, there might be more requirements that will have a scheduled lab. So by, on this Wednesday at 11, we're going to be in the lab working with this equipment to gather data or gather information about this particular set of events, and we need to prepare for that and so forth. So both will happen. However, these office hours, or the lab time, I will make sure that I am available for consultations and for you to come and sit down with me and perhaps verify what you're doing or get feedback on what you're doing or so. Because again, we're moving away a little bit from that associate level where it was a lot of control week by week by week. Show me this, do this, to where you might have an assignment that stretches out over a couple of weeks. So the due date is not until a month from now, but then utilize these lab hours to come in and say, like, this is where I'm currently working on, this is how far I've gotten, or this is the information I gathered, this is what I catted up, this is what I programmed so far, and we'll have a look at it together, and I can provide feedback on it so that when you go to turn it in, you don't find out then and there how you did, but that it's something that is worked on over time. Does that make sense? So the assignments will be a lot bigger. Excellent. Who saves OC? Ah, gotcha. Let me adjust that. Do, 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 do. Gotcha. Do you want me to change that nickname, or do you want to keep it? Gotcha. 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 So, um, so those consultation hour, I mean, we could call it lab hours, we could call it consultation hours. So we'll have dedicated like lab hours, but we'll also have lab hours where you can uh, um, get feedback, and I mean, you have access to the lab as was posted from 7:30 until 3, and then 7:30 until 7:30, Monday through Thursday, to work on these things. And again, you'll enjoy a lot more freedom than what the associate level people will be doing. And at the same time, the expectation is that you're working on things and delivering much larger pieces at a time. Location, Building 24. Has anybody not been to the new building yet? Does anybody need an orientation of where everything is at? And I'm looking at three of you OGs, for example. Do you know where everything is? The different rooms? Gotcha. Well, if you need a better orientation, let me know. We'll figure that out. Or if or and as we are working with things that are equipment wise, if yeah, where is that at, or where can I get that? We'll figure that out in conversation. Okay, so course description. The course focuses on programming for industrial hardware control. Students will work on seamless information and instruction flows between various industrial devices from the perspective of programming. Experience will be gained in programming in the most up-to-date environments used in industry. Students will program in C++, C#, Python, and other languages in the application of a complex industrial system. The class will analyze the current state of the ever-changing ecosystem of programming environments and relate them to practical applications. So this course description is written from sort of a generalist point. I have picked Python to be the language for this course. I assume that you guys know enough sort of C++ style languages that you can continue to develop that um, on your own as well. And also what you pick up in Python you should be able to pick up more C++ as well. We'll talk about that. But I picked Python for this particular iteration of the course. Program outcomes. So this is for all of the BAS meta. So program outcome number 1. Devise solutions to broadly defined engineering problems in complex mechatronic systems through the application of knowledge, techniques, skills, and modern tools of mathematics, science, engineering, and technology. So we're going to do that in the next 6 quarters. Second, design systems, components, or processes meeting specific needs for broadly defined engineering problems for mechatronic systems. We'll also be doing that. Third, compose written, oral, and graphical communication in broadly defined technical and non-technical environments. So, presentation skills, expression skills, all of those things will be practiced as well over the next 6 quarters. Evaluate appropriate technical literature for application in mechatronic systems. We'll be doing that. 5. Evaluate the results of standard tests, measurements, and experiments for the improvement of processes, efficiency, and sustainability in mechatronic systems. And then finally, 6th, build effective technical teams both as a member as well as a leader. Any questions on the program outcomes? Excellent. Crystal clear. Then learning outcomes that are specific to this course. Transform specifications into an industrial application using appropriate software engineering methodology. 2. create robust and sustainable software solutions in order to mitigate security, safety, and hardware control risks. 3. Write code that successfully compiles and executes for hardware control and data manipulation using common industry languages such as Python and C-based languages. So if any of you have previous experience with Python, you might chuckle a little bit at number 3 here. No? Good. No chuckling. 4. Integrate stakeholder specifications into effective software design. And then 5, finally, collaborate effectively in the production of effective software design. Thoughts, questions, comments, concerns about the learning outcomes of the course? Yes, it's a type of nasty snake. Definitely is. Yes, that's also true. They did name it after Monty Python. Grades will be determined by the following weighting regime. So attendance, 20%. And that's because, again, we're relying a lot on information transfer and discussion in these lectures. So that's heavy on the participation. Now, if you miss a lecture or so, or arrive late, let me know in the first break or so that you arrived late. And if you miss it altogether, reach out to me so we can figure out what to do. Labs and assignments will be 40%, and then the final exam is 40%. So, what do you guys notice here if we compare this to the associate level? No midterm in this particular course, correct? The final is weighted way, way heavier. Way, way heavier. And you'll see that as a pattern through all these courses. Um, Ramp up your anxiety levels. No, the intention is to hopefully we can get to a point that anxiety is less. It's not about ramping up the anxiety levels, but it's a little bit towards being able to deliver something um, at a particular time under particular circumstances and being satisfied and happy with what you delivered. So that hopefully we can do the preparations throughout the quarter to a point where that if sort of the journeyman test is like I need this done by 3 o'clock, and this is my expectation, and that you deliver on that. So it's so trying to basically emulate what it would be like for you guys as you, because now you're not just some schmo running around being a minion of somebody else. Like now you're preparing yourself to be a person of authority and responsibility that you can delegate something to or assign something to that then uses delegation perhaps, but like this comes and stays and gets delivered by you and you sign off on it basically. So I'm going to try to make you guys very authoritarian and like this is my decision and I'm sticking by it. Try to poke a hole at it. I dare you. Without hubris. Without hubris. And we'll talk more about strategy as well, because no, it's not about like trying to like surprise and make you guys uncomfortable. It's more about conditioning rather than making you guys uncomfortable. Which is why the attendance then becomes heavier, because it's important that you basically utilize the 10 weeks that we have for a course to chip away at it over 10 weeks rather than perhaps week 8, trying to catch up on 8 weeks of work. So, labs and assignments will be posted and also turned in on Canvas. But again, we have those hours for consultations where you can again show work in progress, get feedback on work in progress, and then when we move into other courses, there will be more stuff going on in the lab where there might not be lab hours, but you're going to have to be in the lab to work with the things that you've been assigned. So going back to that AI course, for example, we might have a slot car racing season going on during that particular course where we have slot car races for 10 weeks. Yeah. It will vary. Some of them will be a written exam. Some of them will perhaps be a take-home exam. Some of them might be an assignment that you do. It will vary from course to course. Schedule. So we have the lectures here, Mondays, 12:30 to 3:30 for the next 10 weeks or so. Labs and consultations. I will be on campus primarily Wednesdays, most likely Thursdays as well. But we have some flexibility there. Monday through Thursday, I will also be on Discord, so you don't have to catch me at the lab. If you don't want to, we can do it over Discord. We can do it in person. We can set up times. I know you guys have schedules and a lot of you are currently working and whatnot, so we'll work around it. But office hours will be Wednesday and Thursdays. Otherwise, we have Discord. Final will be on the 7th of December between 12:30 and 3:30. And then grading scale, A to F, as you can see here in the syllabi. Next, text, references, learning materials, etc. Required reading materials and software will be provided during the course. Students will be required to access and search databases available through the CPTC library for articles, journals, papers from scholarly sources. So you're going to start to see a difference here when it comes to turning things in. You're going to have to, again, express yourself and back up what you're saying with things like peer-reviewed papers, articles. You're going to have to present your sources and those kinds of things. So the scrutiny will be higher, and you need to be mindful of how you when you state something, you need to make it clear what is it that you're stating, and if it's true or not, and how can you prove that that's true or not. You'll be required to utilize online resources for further research and develop your skill set during the course. We will be talking about specific things like, so we'll talk about variables, we'll talk about loops and all that. You're going to have to read beyond that, push yourself beyond what is just said. You cannot just listen and then do good. You're going to have to listen, try, develop, make it your own, and then present and back up presentation to be successful. But we'll talk more about that as well. Policies and procedures. There's a couple of college policies here. If you have any questions about those, reach out to me and we'll try to figure out, put clarity into that if there is any unclarity. Program policies. These, however, are ones that me and Jason have written. So no food or disposable beverage containers are allowed in their lab. You can use reusable beverage containers, and if they have a lid. Labs are organized into zones by subject matter. Each class has a zone in which lab work for that course is to be conducted and accomplished. Students may not, under any circumstance, use equipment in zones for classes they have not yet taken, except for the fifth lab, which is the big open space between machining, us, and NDT. All other zones are not to be used for work in this class except by instructor permission. Fifth lab and the upstairs computer lab are available to work in regardless of the class you're taking, provided they have not been otherwise scheduled. Additionally, Club MEC members may make use of the digital collaboration lab upstairs, which is where all the 3D printers are. Cleanliness of the zones in the classroom are a responsibility of the entire class. A morning walkthrough will be conducted daily by instructors, and up to 2 points daily will be subtracted from all students' attendance grades for that week for any breaches of cleanliness caused by student activity. No student will have their attendance grade brought below 0. Any papers or other such materials left out at the end of the day will be treated as garbage and disposed of. All computers should be signed out of at the end of each day. And these are rules that apply to every student in the building from our program. All classes in the mechatronics program have a zero tolerance for harassment of any kind. Any student witnessed by an instructor or reported by multiple persons to have harassed by the definition laid out in the Student Conduct Handbook that is available on cbdc.edu will be removed from class for 1 day for each incident that occurs. The incidents may also be referred for further disciplinary measures in accordance with the handbook at the discretion of the instructor and or victims of said harassment. Student who's missing either more than 50% of their assignments or attendance by week 5 may receive an automatic failing grade at the discretion of the instructor. A student missing more than 2 consecutive days in a row, so 2 consecutive lectures that is, may receive an automatic failing grade at the discretion of the instructor. But I don't see that we would have to come to this ever because we can talk to one another and figure things out. Plagiarism and academic dishonesty will not be tolerated. Any instance of academic dishonesty as defined by the Student Code of Conduct will receive an automatic 0 for the grade with no allowable extra credit for makeup in that class. The incident may also be referred for further disciplinary measures in accordance with the handbook at the discretion of the instructor. Can anybody tell me what academic dishonesty is? Yeah, taking credit for somebody else's work. Passing off somebody else's work as your own. No, it's going to be very difficult considering the nature of the program that you're in. Are you allowed to utilize other people's work, though? Yeah, no, absolutely. You may absolutely use other people's work as long as you give them the proper credit and point that out that this is this particular organization, person, industry's doing. And that's actually not a bad thing at all to do, because that could be, I mean, the human human development and human success is based upon our ability to collaborate. Absolutely, both machine vision, AI, data analytics, IoT. I mean, the whole thing is about applying what other people have done in combinations to create something sort of for a specific application, for example. Absolutely, even in this class, and Python is an open source language, hence its popularity, um, which means that we'll we'll definitely be borrowing from what, or, you know, using what other people have done before us, giving them proper credit. But then, I mean, and now we're going off track from the syllabus, but there's no to very little merit to create something from scratch when there's somebody who's very good at it, who's been doing it for a long time, has done something that's very smart. And that's one of those judgment things that we will be working on um, um, developing as individuals. But at the same time, we can't pawn it off as our own. It's very important that we recognize the effort of others. And it's also, you're going to see that we're going to be using, since that's another big difference between the associate and the BES. In the associate, we're dealing with a lot more sort of black and white, digital, one or zero, super easy facts where, you know, yes or no, too hot, too cold, on, off. There's going to be a lot more judgment calls and gray areas here in the BES or in the bachelor level. So there it's very important to, I mean, you will be using other people's work as a point of discussion as well. To say, well, this person said so, or this organization says so, in regards to this, what can we decipher from that, or what conclusions can we draw from that? So hence why you guys are going to have to do a lot of research on your own. Which sort of segues nice into group work is essential in mechatronics, and the ability to participate effectively in groups, both of your choosing and those chosen for you, are important outcomes of work in this program. As such, the instructors take serious observation of how groups work in the class and in the lab. Both lack of participation and denial of access to participation are not acceptable behaviors. If an instructor observes, or if documented evidence is provided to them of either of these offenses, the instructor will meet with the student in question to discuss their issues. The instructor may at their discretion assess a penalty on the assignment not to exceed 50% of the grade. So value group work very high. Finally, and this is rooted in a state law, the manufacture of anything intended for use as a weapon in the lab is prohibited by school policy and may also be a crime. Attempts to produce weapons or parts and accessories thereof will not be tolerated. Consequences for violating the policy will vary from loss of equipment privileges to referral to student conduct inquiry to criminal investigation, depending on the nature of the violation. So, please don't manufacture any weapons. Then other information, disability statements, library resource center, student code of conduct, veterans resource center, all present in the syllabi. If that's something you want to explore further, or if you have any questions about it, reach out to me and we'll explore it together. Thoughts, questions, comments, or concerns about the syllabi? Okay. Yeah. Yes. Very good question. So the question is, the math and the physics classes, all of these classes are to be provided on campus. And since the COVID thing, online or in person, I cannot guarantee one or the other. But there will be an opportunity to take them. However, they are aware of when you guys started, and they're aware of this flow. So they will be offering them based upon your cohort's progress through the program, if that makes sense. So Math 142 should be offered this quarter. Please let me know if it isn't. Next, excellent. Math 151 should be offered next quarter. 52 and English 235 the following. Physics and Psych 311 should be offering further on there. And then the follow-up Psych and the Philosophy 310 should be followed there. after. Does that make sense? That they will be running. Um, Another cohort will start in the spring. Is the intention. So if something happens and you botch or miss or uh, skip one of these gen eds, there, as more cohorts start, there will be should be an increased number of opportunities to take these classes, if that makes sense. Yes, I believe so. I don't see any problem with that. The one Physics 211 and Physics 222, those I do not believe exist. They exist in different places, but I'm not sure if they're the same as we've offered them. Me and Jason wrote the outcomes for these two. So I think there is on the state's books the Physics 211 and 222, but it's contentless. So we put the content in there and did that so that it should be a useful physics course that would help you with the electives. So if you take dynamics and kinematics, for example, that course, um, you will have a lot of help out of those physics courses, for example. Oh, and process control. Yeah, it seems like it's very gen ed heavy, and that's because, and it's the same, the program outcomes for the BS meta is all aligned with ABET accreditation requirements, because the intention is that as soon as one of you guys graduate, we're filing for the ABET. We need at least one person to have gone through the program to start a process, and once hopefully we're okay for that, then retroactively all of you guys' degrees become ABIT degrees. But it's sort of catch 22 or chicken and the egg. You need one graduate to get it accredited, and then everybody gets accredited. Uh, Good question. I do not know by heart. Accreditation Board for Engineering and Technology, ABET. Accreditation Board for Engineering and Technology. See, no, they will just drill me full of holes for all kinds of questions on how assessments were being done and the content, the scrutiny, the quality, all of those things will be judged by ABET, and they can't judge that until somebody has gone through the whole thing. Because I could be saying that I'm going to do all these things and then I don't do it. It's actually a really good process. I liked it a lot because they're saying things like, in order to get ABET accredited, the instructor or the professor, the person teaching, has to be the one that is responsible for assessments, has to be the one that actually wrote the courses, a lot of things. So a lot of schools would have an issue passing it because they pawn off a lot of these things on other things like curriculum developers or um, grad students to um, do the correcting of tests and whatnot. Let's see. Some of us are having a hard time using. Okay, that's something that we definitely need to um, square away. So right now, are you not in it through the bill? or that's very good to know. I will get this to the dean um, by the end of today. Because that is, yeah, that is most likely above my pay grade, but not high enough that I can't be troublesome about it. So we'll figure out what to do about that. Excellent. That's not excellent, but excellent that you're letting me know. Okay. So final thing before we actually start with today's lecture, and then we'll take a break to stretch our legs, go to the bathroom, get some more coffee. COVID. So COVID restrictions. We're currently operating on these COVID plans. So which means that anytime you come into the lab, you need to sign in online saying that your student ID number and you'll have to take a questionnaire. They will ask you what building you're going to, what building you've been in, if you've been sick with different symptoms, have you been traveling, etc., etc. So you go through this questionnaire and you do that online, and then you hit submit, and then you have to go to a check-in spot where they will hit you in the head with a touchless thermometer and take your temperature and uh, register you that you're on campus. So that's the start of the process that you have to go through in order to go into the lab or into the buildings on campus. From then on, 6 feet apart, so social distancing, wear face masks, and when we're operating joint equipment that everybody uses in the lab, double glove. So there's gloves available in the lab, in our main lab, where you wear 2 sets, and the idea is the first set is the non-compromise layer that protects you from the outside and the outside from you, and then the second layer is your disposable layer so that you can touch things and work with things, and then you can take that outer layer off and replace it with a new one if those gloves get dirty or compromised or so. Um, for the associate level students, they have much stricter requirements on them only being allowed to come in at designated times. They basically have schedules for, because if let's say they're working on the hydraulic trainers or so, there's a limited number of students at any given time during the day where they have to come in and do their work and then leave. You guys have a lot more flexibility. Granted, this particular quarter there is not any equipment in the lab that you have to have access to other than perhaps the computers if you want to do assignments on the computers at the lab. So you guys don't have to sort of pre-check with me, but you have to stay 6 feet away from people, wear masks, and then wear gloves if you're touching joint equipment. No, and it's like talking to a brick wall. They lock all the doors, so somebody has to be there to sort of prop them open or let you in. So so yeah, one of us has to be there first. Yeah, and so if you're heading in at any time between like Monday and Thursday, or on a Friday, um, reach out to me on um, Discord, and I can let you know who's going to be there or try to get a hold of that person to make sure that they keep an eye out for you. Um, and you can also reach out to Mike here on Discord and see if that coincides, and we'll try to um, fluently arrange it if that makes sense. Granted, we'll have a lot more better access this quarter because of three adjuncts and then me and Jason as well. So we have pretty decent coverage for the most part of the week. Um, I'll try to find a schedule and post, but building 23, and unfortunately, most of these check-in people are like 7:30 until 9:30 in building 23, building 19. 25, I don't think has a check-in. I think we lost ours as well. But the safe one to always go to if you guys are driving to campus, drive over to building 17 first. That main entrance where they have the welcoming center and all that. I think that's manned. Yeah. Right? And which one of them show up at like 5:30? So, yeah. Yeah, let's change the topic. But yes, correct observation. And those are the correct observations. Those are the type of observations I will be looking for in the next 6 quarters. So excellent. Um, you know, um, data turned into information, turned into fact. Yep. So so until and we'll be going through like so each Monday we'll talk about if there's any developments in this COVID thing. So last quarter a big upset was that not the state of Washington, but the higher education state of Washington decided that if you'd gone outside of Washington, Oregon, or Idaho, you had to self quarantine for 2 weeks. Um, that restriction has been lifted. So when you take that questionnaire, it will now ask if you've done any international travel. So, so these things, uh, I think you can actually. You're not supposed to. Yep. Yep. Currently, because we were exploring going to Germany, Germany has now so that if you go get tested, I think 24 or 48 hours prior to departure, and it's from a legit testing center, and you bring that test score of negative back with you, they will let you into the country based upon that. Yeah, no, like it's it's changing. It seems like, but we'll still have these. We'll talk COVID once a week to see if there's any development or if you guys come up with any questions, thoughts, comments, concerns, observations, etc. If there's anything that makes you guys uncomfortable or uncertain or that something that you're uh, feel the need to address, let me know at any point during the week and we'll deal with it. So the idea is for you all to feel safe and to be able to do your job at a disadvantage, obviously, because this is not fun for anybody. But our intention is to keep you guys safe and healthy. Yep. Yes, Mike sits on 2 chairs. Good question, and we're actually going to be addressing that here as soon as we've taken a little bit of a break so that everybody can stretch their legs and whatnot. So we'll take a 15-minute break, get some oxygen, get some coffee, stretch our legs, And so you'll see every time you take a break, I'll pause the stream or stop the stream, and then we'll meet back here, and I'll start the stream again, and we'll continue on. But here at 2:20 p.m., we'll meet back here, and we're going to get into the actual programming lecture part of today. So see you guys at 2:20. Let's start the stream again. I'll see if my little bobblehead starts moving again, and there we go. Okay, so Industry 4.0, programming for Industry 4.0. So the question we should ask ourselves then is, so we will be programming for Industry 4.0? Yes. Or first of all, before we agree to anything, let's find out what Industry 4.0 actually is. So this is a term that gets thrown around a lot. So we need to figure out what is Industry 4.0. So we go to a couple of different sources. So according to Chris Daborn from behance.net, has this infographic that says Industry 1.0, or the first industrial revolution, was the mechanization of manufacturing with the introduction of steam and water power. Okay, I've heard that before. So basically, first industrial revolution came with the steam engine and the ability to have a power source that led to sort of somewhat of perpetual motion other than hand cranked and donkey twirled. In the second industrial revolution, mass production assembly lines using electrical power. So the introduction of electricity and the electrical motor that allowed us to have assembly lines. Okay. Third industrial revolution, automated production using electronics, programmable logic controllers, PLCs, IT systems, and robotics. Well, that kind of sounds like, that sounds fancy or new. I thought, or it could be a conception that 4.0 was IT systems and robotics. Okay, so what did it say about 4.0? The smart factory, autonomous decision making, a cyber physical systems using machine learning and big data analysis, interoperability through IoT and cloud technology. Okay, so we have then 4 industrial revolutions. We're missing some things. It doesn't say anything about time. It doesn't have any specifics. I mean, does anybody remember when the first PLC came online? Older. Late 60s. The Modicon, like 1968, 69, General Motors started bringing in like actual PLCs. So, and then it talks about IT systems. As sure as stuff, that's 90s. And I mean, you could argue that it wasn't really until the 2000s where we brought IT into business properly. And robotics 80s. So that's a significant time span. Mass production assembly lines. So that Henry Ford, so the Model T Ford, that's like right after World War One. So 1918 to I guess then late 60s. Okay, so let's look at some more sources. We have SACA. Now I can't remember, but since we have the website here, we can look up what SACA. But that's some. Who are SACA? Should we trust them? SACA, Smart Automation Certification Alliance. Okay, they're saying that the industrial revolutions were 1784, Industry 1, mechanization, steam power, and the weaving loom. 1870s, mass production, assembly line, electrical energy. Industry 3.0, automation, computers, and electronics, 1969. And then Industry 4.0, today. So why, okay. So now that's sort of, so far these two sources are in agreement with one another. So Industry 4.0, cyber physical systems, IoT, and networking. automation and electronics has already passed, and mass production has way passed. So now they're saying about the same thing, but now we also have years. So let's look at a third source. We have Industry 1, 1784, and this is from the Northern Auto Alliance. Industry 2, 1870, Industry 3, 1969, Industry 4.0 today. Okay, so we have three sources now. Two that confirm the activities, two that confirm the dates. Now let's look at a fourth one from Bosch. Their DFKI 2011, so slightly dated. That's 9 years ago. Connected industry is to a large extent self-organizing. The lubricant of a smart factory is information, which tells the machinery how it should organize itself in order to complete a certain job. So stage 1, late 18th century. So that's 17, what did the previous sources say? 1784, yeah. First mechanized manufacturing equipment powered by water and steam. So the first mechanical loom. Introduction of mass production with the help of electrical power in stage 2, or the second industrial revolution. First assembly line slaughterhouse in Cincinnati, which is interesting because if you remember our theory, when we talk in lean, we talk about Henry Ford actually not being the first doing line production. That was that slaughterhouse. Henry Ford made it much bigger though than what the slaughterhouse did. Stage 3, or the third industrial revolution, early 70s, use of electronics and computers to automate manufacturing worldwide, 1969, first PLC. And then stage 4, cyber physical systems, real objects and virtual processes are interlinked, connected industry, smart factory. So, okay, so we have four sources now that sort of say that this is a correct statement of what the fourth industrial revolution is, or Industry 4.0. Have you guys noticed that they don't put a date? There's no year on today. Why? Yeah, so yeah, that's I think that's a we're dealing with a lot of. So Veine, what were you gonna say? Very good. So that's an excellent question. That's an excellent question, and the answer to that is most people don't know. Is it that simple? You will find, and this is something in here in our region. So, you know, now I'm gonna make myself unpopular again. If we look at Industry 3, that started in 1969, automation, computers, and electronics. If we look at regional industry, or well, how to phrase this? If we look at regional industry, is the norm automated production using IT systems and robotics in our region? Yes. Depends on what industry. Questionable. Depends on what industry. We're comfortably in Industry 3.0. Okay. Now, so now we're starting to get something there. Based upon visits in industrial survey, it appears that we're firmly in Industry 2.0. And this is where, this is where this is going to be very important. And again, comparison between bachelor level and associate level is that we're gonna have to call it on some of these things, and we have to back up what we're saying. Where eyewitness accounts, that definitely counts for something. Uh, Limited sample size, perhaps, but let's say that Applied MEC, or sorry, Industrial Survey and Club MEC has made 30 visits. How many of those were firmly in Industry 4.0? How many of those were firmly in Industry 3.0? How many of those were firmly in 2.0? I would tend to agree based upon observations and also based upon how conversations go when it comes to the topic of mechatronics, we're still in 2.0. A lot of places in 2.0. A lot of Boeing's subcontractors are in 2.0. Okay? Okay. Okay, so now 2.8, I like that one. But yes, now we're peeling the onion and we're basically there are PLCs that are automated components, but those systems are not integrated with one another. And then it's tough. Like, how do we call out, like, when do you qualify for 3 versus 2 versus 4? Like, if we do a little bit of 4, are we now 4, or are we, or is there like a pivoting point where we fall over on the other side? Nobody knows. Go ahead. Correct. Yeah, and go ahead. Yeah, no, and that's uh, and it's and you will find this confusion a lot. Like that 1 and 2, like we know we're way past 1, and 2 is is the one that is easily recognizable. But yes, I would agree as a production engineer, uh, how your production planning is what will determine. So from a production engineering standpoint, if you're in industry 2, 3, or 4, will be based upon your production planning. Um, but then from other perspectives that might become more or less fluid or rigid. However, an interesting point though is that can you do 4 without 3? I would say so as well. It would be very hard. That Yes, I would argue that you need digital I/O in order for 4 to work. Yeah, and that's the good thing, and that's sort of the point I want to get to is that you don't have to. You can jump from 2 to 4 and get 3 along the way if you're paying attention. And that's very good for us. Very, very good for us. So, Industry 4.0. they put it down as cyber physical systems. And this is where programming comes in. And what I was saying when we were going through the beginning of this course is that it doesn't matter how you feel about programming. You need to basically see it as just like any other tool. It's like a wrench, a welder, a hammer, a multimeter, a computer, a PLC. Programming, see that as just another tool in your toolbox, and you need to embrace that because that will be the tools that you will be using, one of the primary tools that you'll be using when working in the 4.0 environment. Now, we're going to demystify, hopefully, a lot of sort of the what should we call it? We will demystify a lot of the preconceived notions of what it means to be a programmer or being a software person or so, because that's not really how we will wield these things. We are different, and we'll take a different approach than people who work primarily with software, and we'll be taking a slightly different approach to people who work primarily with only hardware, so like the traditional mechanical, electrical engineers and whatnot. We're in between those two realms, and there will be our own application for it. So if we try to define Industry 4.0, the fourth industrial revolution, or Industry 4.0 as is known, is the ongoing, keyword there, ongoing automation of traditional manufacturing and industrial practices using modern smart technology, which is a stupid term because it doesn't really tell us anything. Like, smart is a super dumb term. Large-scale machine-to-machine communication. Now we're getting into detail what smart could be. So M2M, remember that designation, machine-to-machine communication, and the Internet of Things. That is something we'll dive deep into later in the program, but programming will be a huge part of that. Are integrated for increased automation, improved communication, and then self-monitoring, and production of smart machines that can analyze and diagnose issues without the need for human intervention. And this comes from an article in TechRadar, May 2020. And, November 2019. This was retrieved from TechRadar in May 2020. So you can see here, like by this definition, where it's very much so that like 3 and 4 are very blended. So 4 is an addition to 3. So from our perspective then, what are we looking to do? So we will be programming for Industry 4.0, and there's a couple of things that we're looking for. One is we're looking for monitoring. So we want to be able to monitor processes. We wanted to be able to monitor systems. We want to be able to monitor components. We want to be able to monitor people, like the different aspects of an entire system or multiple systems together. We want to be able to monitor them. Control. And this is less strange because we do that already in PLC. PLC's control. However, now we are looking to control in regards to the cyber physical. So we're looking for control that is a PLC is control on a hardware level, even though it uses software. Does that make sense? Like a PLC uses ladder logic or sequential functioning chart or whatever, but it's a hardware control. We're looking for cyber physical control. Data acquisition, data sorting and storage, and then data information presentation, where data leads to information, leads to presentation. All of these 5 categories are things that we're looking to do in order to program for Industry 4.0, which puts a which I mean, and this, right here you see the why this is a standalone course is because monitoring, control, data acquisition, data sorting and storage, data information presentation, basically taking data, manipulating it, and visualizing it so that it is useful, basically taking data to turn into information. We'll talk more about this later, and into presentation. These are 5 vastly different styles of programming. I know some of you have more or less programming experience. Some of you are quite accomplished programmers. Would you agree that this is basically 5 completely different avenues? So, as mechatronics people, we have to be able to do these well enough that we can do it. Well, we have to do it well enough so we can get paid for it. And that's also why we're useful, is because we can do all of these things in the modern workplace. Some regions more so than other. If we're talking about Germany, a lot of European industry, this is a requirement that you can do these 5 things as a single person or team, and that your systems can do these 5 things. Here, they are not quite there yet. Again, you're part of a top 10 program. But that's really good because you guys will be pioneers and there is less competition. Now, this is what influenced the choice of language and why we're going to go with Python. So there are many different programming languages. There is, Visual Basic. There is C, C++, C Sharp, Python, ABC. There is a whole bunch of languages. Python was released in the early 90s, and it's currently on its 3rd generation. It's open source software. And the nice thing about it, there's 2 things that are super awesome about it. One is 3 things. 3 things. First, it's designed to be extensible. So when Python by itself is very light, there's not much clutter in it at all. It starts out as very like just a little shell, but it's super easy to add onto and build onto it. Like if you want to go back and change things, add more to it, you can do so after the fact. That's a huge bonus to it. It's a very efficient language. So you can do a lot with very few lines. It's very forgiving on syntax. You don't have to, it's not, if we take machine languages like programming and compare that to human speech, your formality, your use of nouns and verbs and all that, Python is pretty forgiving on all of those things. So the fact that it's light, easy to use, and then open source, so everybody uses it. So if you work in the gaming industry where you develop like video games, high-end video games for Xbox, PlayStation, and PC, Python. If you work in industry, but regular production, Python. If you work with IoT, Python. Working with microcontrollers, Python. If you work with car systems, Python. If you work with, what else? What have we missed? Basically, Python is everywhere that computers are being used. So a very good language to learn. Oh yeah, data analytics, Python. AI, Python. Yeah, there you go. Another good example. So learning this language, and it's open source, so it's easy to find. There's a ton of, or thousands, hundreds of thousands, perhaps millions of people that are really smart that are using it day by day. It's an open source language, and they tend to share and answer questions for us, which makes it very easy for us to, as if we can understand what they're saying, we can do a lot of neat things without having to be super smart. Or it's not about smart or dumb. It's about people having the advantage of having done it more than us, longer than us. We can catch up pretty quickly. So Python can and is currently used to monitor, control, acquisition data, sort data, store data, pull data, and process that data into information, or process that information into pretty pictures so that we can understand it. Python has all these things already developed by very clever people from multiple industries. It's a very good language to learn. So the sum of L is constant. So if Python is so awesome on all these things, what is it bad at? It is super slow. It is super, super, super slow. And explain to everybody else, or anybody now who's curious, what does slow mean in terms of languages, computer languages? Very good analogy. I really like how you use the PLC as a comparison. And yeah, and the difference between the two is catastrophic, really. From a human's perspective, can't really tell a difference. But from a process perspective, Python is a snail compared to a cheetah. Now, um, the good thing, though, however, and this is why we can't just learn Python. You guys are also going to have to. We're not going to spend much time on it in this particular course, but you cannot forget about C++ or the C-based languages because C is extremely fast. C++ is extremely fast. So when we're programming servos, when we're programming those like things that need critical decision making very quickly, C++ hands down. Now the good thing with Python is that if you run into something where you need speed, Python is actually really good at playing nice with things like C++. So we can combine Python and other programming languages to do is like, oh, we need to do something fast. Like, let me call upon C++ to fix this for us. So combining those two can be done, and Python allows it. C++ doesn't like Python at all, but Python likes C++. So it's a light language, easy to use, easy to learn, huge support online. Can be used for just about anything. Just keep in mind that it's slow, but we can combine it with other languages. And it offers a path to do monitoring, control, data acquisition, sorting, and visualization, all those things. So that's a regular Python. Uh, you're going to see that this course is going to be split into two sort of prongs. We have Python, and then we have Circuit Python. So Circuit Python or MicroPython, if we start with MicroPython, is a lean and efficient implementation of Python 3. So this is something you'll find that there's different versions of Python, different sort of editions, and we're currently on 3.8. So you can imagine what it was like for me. When I started my computer this morning, I got a notification that my computer just updated to Python 3.8. I was like, great, the day of classes, I get a new version of Python. Hopefully nothing has changed very much, but we're still in generation 3. So MicroPython is a version of Python 3 that includes a small subset of Python's standard libraries and is optimized to run on microcontrollers, so hardware, and in constrained environments. So what they've taken is that basically, if you remember, I was talking about this little shell that you can expand on. You can take very little piece of Python and just put in the bare essentials to solve whatever it is that you want to do, particularly then on a hardware level. You don't need to take on like the entire package. So C++ comes with an entire package. A lot of other programming languages comes with a lot of stuff. And it's very hard to sort of shave off things. Python comes like you can take the very basics and just add little pieces, barely enough for you to be able to solve a particular task. And MicroPython is an example of that. And if we go by, so MicroPython is its own organization. If you go to the web page micropython.org, they say about themselves and about Python. It's the fastest growing programming language taught in schools and universities. It's a high level programming language, which doesn't mean that it's exclusive. It's just how close to ones and zeros is it? It's pretty far away because it's a high level, basically. There's a lot of junk between the ones and zeros layer and layer that Python is on. It's designed to be easy to read, write, and maintain. Its support modules and packages is easy to reuse for your particular. So you can take what other people have done and apply it to what you're trying to do. It has a built-in interpreter, which means there are no extra steps like compiling to get your code to work. So Jesse, let me tell everybody what that means. No compiler. Yeah, you basically copy your Python to your microcontroller, and then um, it hopefully works. You don't have to sort of connect your little cord, hit compile, upload, and all that. Yep. Yes. Very important distinction. It will do what you told it to, not what you want, what you told it to. But yes, basically you're going to see that your little microcontrollers pop up on your computer like an external hard drive, and you just send your code over there, and it'll spring to life. Hopefully. So CircuitPython adds hardware support to these the features of Python. So it's basically an earmarked or purpose-built version of Python that is meant to run on microcontrollers. And then if we look at circuitpython.org, so MicroPython, CircuitPython, very similar. They say Python is the fastest growing programming language. So you see, very same. Um, Basically dedicated to run on small microcontrollers. Now, if you go with CircuitPython or MicroPython, it's more or less semantics. We'll focus more on CircuitPython because I believe most of you have hardware that is more so compatible and more so supported by CircuitPython than by MicroPython. But and this is the nice thing about this course is it shouldn't really matter. At the end of these 10 weeks, what I'm trying to get you guys to is a point where you are comfortable enough with Python to keep on learning it by yourself and being able to make it do new things. Because it's impossible to sort of, you can't learn all of it, but you need to learn how to learn new things about it and change up your skill set. So 2 prongs for MEC 330. Regular Python as a tool in our toolbox. That means working with AI, data analytics, monitoring, turning like data into information, all those things. So it's going to be a little bit of mat stat in there and all those things. That tool we're going to put in our toolbox. We're not going to be masters of how to use it yet, but at least we'll have it in our toolbox, and then so we can use it in all the following classes that will be coming after this. And then CircuitPython is for working with circuitry and hardware and is an application for our application box. So you'll have C++ and you'll have CircuitPython to now start to really on sort of a hardware level do hardware applications. Both of these will be very important for all your future work. So today's goal before we're done is to set up our computers to work with Python so that next week we're ready to dive in to starting to learn how to use these two different approaches, but using Python for both of them. So the first thing we're going to do is to see if Python is installed on our machine. So I'm assuming, so I know that some of you are weird and use my Macintosh or Mac. I guess they call it Mac now. Um, well, left-handed is not weird, but using Mac is weird. I guess, well, I mean, So if you use a computer with only one mouse button, um, you're this all works on Mac. It's just that it's going to be a slightly different approach. That you're going to have to use that like the Apple symbol command shortcuts and stuff like that. But it will work on Linux, it will work on Mac, and it will work on a real computer. So the first thing we're going to do is in your command prompt. So if you go to your search bar in Windows, Todd, what do you use for Mac when you want to open the command prompt? Excellent. Excellent. So if you type in CMD in your search field, you'll open it, or you can type in command prompt. It will open this window here, right? Now, if you type in Python, two things can happen. One is that you'll get these three little arrows. That means that Python is on your system. If you get something like not recognized command, that means that Python is not installed on your computer. Now, if you use fancier versions of Windows 10, it might even prompt you, would you like to install Python? It'll ask you if there's an application that you want to open. If you don't get that prompt, you can go to python.org. So if we open that web page, let me bring that up here. That page looks like this, python.org. We can go to download and then download for either Windows, Mac OS, or Linux, whatever version you have, and just download this and run it. And it will install Python on your computer. And this provides us with an interesting feature, which is that we can run and test small snippets of code in the command prompt here, just for sanity checks or to test things, and sort of a fast and high-speed, low-drag way of validating codes or testing things or experimenting with things. Will we use this environment to code? No, not really, but we have the ability to run it here. This will also matter when you want to run Python programs that are not yet fully compiled. So, get test here, print. Yep, works. So you'll see here that there is no semicolons, and as like print, hello there, and it prints hello there. Python is very nice that way, that it's very little formality. Yes. I got you. Yes, that's a good. Yes. And that might actually change depending on how your original computer is set up as well, because I think mine only asks, do you want this to be for the user or for the entire computer? It's the only thing that it. Yeah. Yes, that's very true. So yes, please keep that in mind. Please keep that in mind. So once we've done that, we can verify if it works. Again, we open our command prompt. Again, just type CMD or command prompt into your search bar. We get something that looks like so, and we type in Python, and we now get these three little arrows, and now we can see to test this, again, a small test, print what's up Python interpreter. interpreter. Test it, and it repeats back to what's up Python interpreter. Now we can close this by either Control Z, and that snaps us out of it and goes back to if we want to run our Windows like it was DOS, or we can type in exit, and that's a way to get out of it. We can also just X this down if we want to close it down. But next up then, now we have Python on our computer. Now we're gonna basically download the tools that we'll be using in the course to work with these Circuit Python and with regular Python. So for regular Python, we will be using a compiler or an editor for each in order to keep these two worlds a little bit separate so we don't confuse ourselves here in the beginning. So when we're working with regular Python, we're going to use an editor called Sublime. And that makes it way easier to debug, troubleshoot, save, and load code, keep up with generational. It will have examples of libraries and things like that. Sort of like using the Arduino IDE. I mean, you could write C++ in a regular text document, but the Arduino IDE is very nice because it will help you debug and things like that. So it'll make us faster, make it easier, and I think you'll quickly see how that works. So if we go to sublimetext.com, I'll bring that up here, and I've already done this, but I'll show you. Seemed excessive to sort of uninstall everything to go through it, because I think you guys would have been perhaps insulted by me going too slow. But if we go to sublimetext.com, here you see an example of what Sublime looks like. It's pretty neat for doing software coding. So download for Windows. I believe they have it for Mac. Yeah, they do have it for Mac and Linux as well. But we download this. It's free to use, but they encourage you to buy it if you like it. So do it with that as you please. But we download it. It will go into our downloads. We install it. And once we've installed it, what we're going to do before we start Sublime Text is that I want you to create a folder on your computer that's called Python_work. So all lowercase letters and use underscore. Why? It's because this is according to naming conventions in Python. And you will see this is very useful when we're dealing then with dumber or older systems, and also when we're using our keyboard to call upon things and work with things, is that we want to use symbols in ways that are systematic across all platforms. So create this folder and then stick it somewhere where you can find it. In my case, I have it here on my desktop. You can see here, Python_work. And this is where I will save all my files that has to do with regular software Python. So we create that. And once we've done that, we can now, let me just rearrange my screens again so I can see. We can now switch over to, we can start Sublime Text. And you'll find that among your programs on your computer. And when you open it, it looks something like that. And now it's already running a program, but new file. So in the beginning, before we set it up to do anything fancy, pretty nondescript, just a terminal and where we can write our code. Next step, let's create our first piece of Python code to let's make sure that this works. So we're going to first save an empty Python file called helloworld.py. So file save as And then in our Python underscore work, we'll create a file and now I already have one, so I'll create another hello world 1.py. And it's important that you type in py here at the end. That extension will make the editor understand that it's Python you're coding in, because I believe Sublime Text can be used for all kinds of programming languages. So if you don't put that py, it will just save it in as a nondescript file, and that makes it more difficult because you won't have help from Sublime Text until you specify what it is that we're working on. So if we do that, you see now that it will open these little tabs, so you can actually run quite a few programs at the same time. So if I compare that to just a regular one, so this untitled one here now is not specified to any programming language. So if I start typing things, you'll see that it doesn't really change any colors or do anything. It's just gray text. But this one here that I specified is Python. If I type print, you'll see that turns red. Oh, sorry. If you'll see that it turns red, and then it turns blue. So you see, like, you're having help with the formatting here because it knows that you're trying to do Python and it will assist you on the way. So red is, not good. Blue is good. Another cool feature is that you can see it sort of auto formulates things for me, or autofill. So if I do one parenthesis, it adds another parenthesis. If I do bunny ears, it'll add the other bunny ear. And then we can hello world in Python. And then since it's Python, no semicolons, no end, no formatting, nothing. The piece of code is done. And now to test it, see if it works, we can either go to Tools and select Build, or you can hit Control B. And you can see here it's sort of automatically set to save all on build. So if you build your program, basically compiling it, it will save your progress to that file. So we hit Build, and it'll run it. Hello world in Python, and it took 0.9 seconds to run this, which is, what do you say, Vayner? Is that fast? Yeah. And you'll probably see, depending on your clock speed on your computer, this will be different speeds. If I do this on a computer that I don't have 3 screens and you guys and a whole bunch of going on, I can squeeze it down to 0.2 seconds, which is still super slow to run a single line of code. But so it's a couple of things to take away from this is that do that folder first, and then save as that it's a .py first, and then start working in it, and then Sublime will kick in to know that you're trying to work with Python and help you out on the way. So that will be, go ahead. Yep, correct. So Sublime Text is an excellent editor for all kinds of programming languages. And that's why we'll use it for our software stuff, our software Python. And you can set this up to do all kinds of fancy things. As you guys will explore resources and tutorials and whatnot, you'll find that people have set the Sublime up to do all kinds of pretty neat like you can even do macros in Sublime Text, which is kind of cool. So that was our first Python program. So if you do this, you set up your computer, and that's the assignment for this week. You will have written your first little Python program, just like that. Now, since we have this program saved, so I'm going to close down Sublime Text. I'm going to go back to how we can use then our command prompt to run Python programs. So you saw that we could type in and test. Basically, if I open that command prompt again, like so. You saw that we could basically type in Python, it goes into this mode, and we can actually do, but with no help now. And we can run Python code. Another thing that we can do is from here, we can go, and if we use old DOS commands, so cd desktop, that will bring me to the desktop. cd, and this is to illustrate why you don't want to use any weird names or formatting on your saved folders, because I want to be able to type this super easy. If I want to access that folder, if I had a space in there or so, this makes it more complicated. So now I'm inside that folder on my desktop using the command prompt. So things like cd space or whatever the name, that basically means that you're accessing a folder. You can also type in dir directory, and I will list everything that is currently in the folder you're in. So basically folder navigating here. So if you want to access a folder, cd and then that folder name. How do I know which folders I can access? You can type in dir, and if you want to back out of a folder, cd ... So this is old school DOS commands. How many of you are not familiar with old school DOS commands? Okay, so we'll perhaps try this out. This is not critical to sort of get up and running with this kind of stuff, but it's good stuff to know. So perhaps on a Wednesday or so we can sit down then and go through a little bit of DOS commands, so you get familiar with just navigating folders using DOS commands. Yeah. Yeah. And I've listed a pathway here. So dir will directory that will list everything that's in the folder that you're currently in. You'll see that in that list is desktop. So then cd desktop, that will make you jump into that folder, and then then you can do directory again. You'll see all the lists of the stuff there. You'll see that your Python_work is there. cd Python_work will make you jump into that folder directory, and then we see our programs in here that you see then hello world.py, hello world1.py. So now I can run those programs by typing in Python and then hello, which is again no spaces, underscores instead, hello world.py, and now I'm running that file with Python, and you see hello world in Python. Or we can do Python hello world1.py, and it runs that as Python, hello world in Python. So you can run your programs in Windows without using a compiler or a microcontroller by having Python installed on Windows. And depending, but so Mike, when you enter the command prompt, will it drop you in OneDrive or will it drop you in user? Because I think gotcha. Yeah, so anybody who's not super familiar with this, want a refresher, so on a Wednesday or Thursday, come see me and we'll do some DOS navigation. And it's not super critical just yet. It's really just really good stuff to know. because it allows you to, again, run pieces of Python code. You can also do little programs, and this goes back to that monitor control, uh, data acquisition, data generation, those kinds of things, is that you can create little tools with Python that you perhaps want to run from Windows or run from perhaps me and Todd are working something. Todd has a Mac, I have an Apple, uh, or PC, whatever. Uh, we can send these programs across and run them uh, without having to have a third piece of software as an interpreter. Because perhaps we've created a tool that we and you'll find this, like, if you're interested in RFID, for example, Python can be really useful to create little RFID programs that allows you to work with RFID and things like that, where you might want to run it off a microcontroller, a PC, a Mac, a Samsung Galaxy, an iPhone, whatever it might be, um, and you just want to bring around little .py files. So knowing how, or run it on Linux or a server, whatever, um, it's not bad stuff to know. And we'll get some more practice with this. So exactly. So the very first step we did there is a good step to do to any computer, is that you make sure that it understands Python, and then you're good to go across all platforms, which is why this is such a robust tool to our toolbox, is because it doesn't matter what system we're on, our tools are portable. Correct. Correct, correct. And all of those things are things we'll explore in the next um, 10 weeks. And it will be so that we're not going to be able to, and you're most likely never going to be able to know everything, but we need to have these basic things that we always are progressing. Which leads us then to our second editor. And there's a reason for this as well, because some of you, perhaps most of you, perhaps none of you, are not used to working with different sort of tools to work with software and programming, um, which is also why we didn't have the Arduino IDE. We now have Sublime, and now we're going to add a third one, which is Mu, MU. So when we're working with Python and hardware, we're going to be using a code editor called Mu, MU. So if we go to codewith.mu, so let's do that. I'll bring up what that looks like. You get very nondescript page that looks like this, where we go a simple Python editor for beginner programmers. We just hit download. We download and install this. And Mu is what we'll be using when we're working with our hardware. So you go here. So you go to codewith.mu, download, install, and then something to be mindful is that when you've installed Mu, and by the way, Mu is awesome also for the reason that I'm separating these is that, first of all, in the beginning, I don't want you guys to be confused between this sort of the software stuff that we do and the hardware stuff that we do. So like it allows us to keep those different. So if one crashes, not all work is lost, and we also can sort of switch between two mindsets. But we are also trying to use as much resources as we possibly can. And Mu has a ton of tutorials, how-tos, and other resources, and especially around hardware, microcontrollers. While Sublime Text has a stuff ton of support for sort of software applications for Python. So we install Mu, and you're going to be prompted with this screen the first time you open it. And you can select either Adafruit CircuitPython or BBC Microbit, Pygame 0, Python 3. So this goes back as to one of you commented, can we work with Raspberry Pis? Can we? Yes, you can absolutely. From a course perspective, I will be focusing on regular Python and the Adafruit CircuitPython library due to the availability of support functions. And I believe most of you have one type or another of Adafruit hardware, be it a Metro board, Circuit Playground Express, whatever it might be, by chance, and also by availability if you need to get one. That's the best supported. So here you could run regular Python 3 in Mu, but you're going to select Adafruit CircuitPython. And hit OK. Now, go ahead. Correct. Can't you, I think can't you convert, like, can't you flash it on there? Ah, yes, that's an important designation then. Uno. Yeah, so that's an important distinction. I'll show you also, guys, here where you can sort of look for compatibility on what was worth getting. So here, when you're in Mu, like the first time, it'll ask you, what do you want to run? And you select the Adafruit products. And if you want to change your mind, or if you buy a BBC, or if you want to work with Pygame 0, there's a ton of resources for Pygame 0 or regular Python, you can just hit mode up here, and it'll allow you to switch very quickly between, which is why we use this editor also then for the circuit work that we want to do. And other than that, it's going to be very similar, where you can work with Python. So once you install it, you start it up, it'll ask you, first of all, it'll complain at you that you don't have a piece of hardware connected. Ignore that. Select the Adafruit products. If you want to change that, you can go in here. Now, this goes back then to what Jesse pointed out. We need to download CircuitPython next. And if we go to this link, circuitpython.org/downloads, this is where we'll get some help. So if I go to that, circuitpython.org/downloads, you will be greeted by this screen here. So you'll see here all the boards that are currently supported, where CircuitPython sort of exists for your board. So I will primarily be using the Circuit Playground Express for my demos in the next couple of weeks. But there's a ton of ones available. But the Circuit Playground Express is affordable and not a bad one. Grand Central is basically a mega, but Adafruit's version. So not a bad one either. Let's see which other ones. The Metro M0 Express, the M4 Express, both of those are good. Very similar to the Arduino that you're used to. And I would probably recommend that try to stay within those boards unless you're already quite comfortable. All of these, the Redboard Turbo I think is also a pretty safe choice. The Boron and those that have all kinds of Wi-Fi stuff, so like all of these boards are awesome. But for simplicity's sake, try to stick within range of comfort. But here's all the boards that are basically already pre-existing, where you can download sort of a setup for Mu that matches your board. OpenMBH7, that's a vision system board that you can do vision systems with Python. So as you guys can see, we're creating the stepping stones to success in future courses. So this is where we will stop then for this week, because the next step for you guys then is to download Sublime or Python, Sublime, Mu, and set those up. Try your first program in Sublime, and then to make sure by next week that you have a microcontroller that you can work with. So for next week, I want you to please make sure you have access to a computer that can run both Mu and Sublime. I want you to have access to a CircuitPython compatible board, such as that Metro or Circuit Playground Express Arduino Zero. So that's an Arduino branded Arduino board, Zero, that's supported. Make sure you have the programming cable for that microcontroller, and then the various circuit components such as breadboards, resistors, LEDs, and whatnot. Does anybody foresee an issue with having access to a piece of hardware next week? If you do, please let me know and we'll try to figure out a way to resolve it. Next up then. So that's basically where, as far as I want you or need you to go this week. Here, next step then, here are some useful resources. So you saw in the syllabi that there's no required textbook. I do require you to use Mu and Sublime. I do require you to have access to a CircuitPython compatible board. But when it comes to books, python.org and python.org beginner's guide for programmers or people who are comfortable with programming, and then beginner's guide for non-programmers, there you will find a ton of resources. Now, even sweeter is, I'm just going to copy paste this link here, is that if you go to this blog Thinkster/free Python books, I'm just going to do that, you will find approximately $1,500 or so worth of free ebooks, all in regards to Python. So it seemed silly to have you guys go and run and buy a book when, and the first time you open this page, it will prompt you to register, give your email, so just click that away. Screw these people. And you'll find here a ton of books that are high-end. This Learning Python, I think, is like 3,000 pages, has everything there is to know about Python as a PDF. Learn Python the hard way, making games with Python and Pygame. We'll talk more about what Pygame, Panda, and those things are. The Python Pocket Reference, also a really good book. And then the list goes on and on. Data structures and algorithms in Python, building machine learning systems with Python, BioPython, beginner's book to Python, hacking secret ciphers with Python, learn pandas, learn Python, break Python, learn Python in Y minutes, non-programmers tutorial for Python, on and on and on. So yeah, about $1,500 worth of ebooks, readily accessible to you. Pull some of those home. But even if you don't pull any of these home, just the python.org's the wiki, and again YouTube and these will provide a ton of references. And also I will be uploading some stuff on Canvas, like cheat sheets and quick tutorials and things like that. I think they had the Python cheat sheets here. So don't give them any information. Like these can be found that are pretty neat. That will be sort of pocket references for different command lines and you know how to do functions and whatnot. So check that out. Pull some books down, and hopefully you'll have all the sort of, if you need to read on your own, support that you need. And I'll add links to this as the weeks pass on, as I find more stuff. So how are we going to be successful in this course? So Python and CircuitPython are tools, just like a multimeter or a welder, hammer, whatever it might be, and we need to get to a level of comfortability that we see it as such. So it's not we shouldn't focus on doing Python or programming as such. It's a means to an end. is a tool that we use to achieve other things that are important to us, that will collect the data that we want, that will control the machine that we want, that will sort this IO from this IO, that will sort this value from this value. It's a tool that we need to learn how to use, recognize and use to be able to achieve other things. So it's important that we know what Python and C++ and any language really, there is no harm done in knowing as many languages as possible, but we need to be knowledgeable in what they're used for and what they're good at. And we need to be able to use them proficiently. So using C++, Python, and CircuitPython, those three primarily, will be the key to success in just about every other mechatronics course and future job that you'll sort of partake into in the next couple of years. Next 6 quarters in terms of the program, and for future jobs, because again, we're trying to get that Industrial Revolution 3 and 4, especially the fourth one. C++ and Python are two important tools that need to be in your toolbox to just operate and work within that environment. Does that make sense? So each week, we'll go through theory, we'll go through examples, we'll go through applications, we'll talk about variables, we'll talk about loops, we'll talk about functions, we'll talk about lists, we'll talk about all kinds of stuff. So you need to understand those, do them yourself as perhaps they're presented to you. And I know some of you guys are pretty savvy already on this stuff, and some of you this might be completely new, but you need to understand those, do them, emphasis on do them, then practice and apply it on something of your own. Now, if you need help to come up with things, that's good things to have discussions about on Wednesdays and Thursdays or whenever on Discord, where you take it and then try to, because again, it's a tool, and a tool is, you've heard the joke, if you have a hammer, everything looks like a nail. Well, now you're going to have Python, and everything should look like something you Python. So look for things to hit with your hammer. It's going to be key that you practice this as a tool. You don't do it for doing's sake. You do it to achieve something else. Maybe you have a list of 5 things that you want to sort in alphabetical order. Maybe you want to pick out the longest word. Maybe you want to pick out the shortest word. Maybe you want to delete certain things. I think these examples will make a little bit more sense as we get deeper, but start tinkering with it and start to wield it as a tool. That's going to be an important key to success. Second, set aside or schedule an hour a day, 2 hours every other day. But what I want you to try to do is make a habit to sit and practice and explore and experiment with Python, so that you create a habit of constantly sharpening your skills and understanding. Because this is an ever-changing, very dynamic environment. I've already sort of ripped on regional industry of being sort of stuck in 2 and not really as deep into 3 as what I would want them, so that they're ready for 4. But they will. And so will you guys, so will your competition. And again, there was a new version of Python being released today. This is all a moving river. Like Industry 4.0 is a moving river. Industry is a moving river. The Python, the tool, is a moving river. So my goal with this course is not to be sort of the end all, here's everything you need to know, and now you know it, and then like we cap it there. No, the purpose here is to make you proficient and comfortable enough to develop Python and programming skills on your own. So you know enough Python that you can read other people's Python to now do vision systems, to read other people's Python and applications to now do universal robots, to now integrate this lathe with this PLC that is all monitored from a Windows computer in a different state, that then back up data to a Linux server that has a historian that's from 1983. Nobody has written a guide on how to do that. It's going to take some research. It's going to take some billable hours for you to sit and tinker with that. Customers will want to have it because they're stuck in 2, they're getting into 3 and 4, and they hired you to do that. So there's nothing that can sort of like the end all, bow-tied package, here you go. No, you need to get to a point where you basically, if you're thrown into the river, you don't sink and die. or you swim against the current. No, I want you to be able to get into this river and float comfortably with it. So Industry 4.0 is changing by the hour, daily, weekly. Python is, a lot of things are. Um, you need to be able to get to a point where you can float and float comfortably. So, to round up today, track down suitable reference sources and perhaps an ebook or two from the links that I provided. Check those out. See where can I look for help. Obviously, you can ask me. You should be talking to your classmates. You guys are the first cohort, so you're number one. You're special. Um, work on that cohort teamwork. There's no specific lab assigned. However, I want you for next week to prep. Make sure that you have a CircuitPython compatible microcontroller with suitable peripherals. Make sure that you have both Sublime and Mu installed and ready to go with. And I didn't show you that from Mu, but if you have a Python work for Sublime, make sure you have another Python folder that uses smaller lowercase letters and underscores for your Mu work. And have a way to back that up. Think about generation or how are you going to save your program so you don't confuse yourself, and have your file storage formatting in place. And that's pretty much it for this week's. Any questions? Any thoughts, comments, concerns? You cut out there a bit. Say that one more time. Uh, I would like, so we're going to go through some specifics to how to interact with hardware. So make sure that you can use Mu, and then by basically writing things in Mu, make things happen on your hardware device. Um, yes. And you're going to see it's very similar between the two. It's just that we're it's I want the whole thing about CircuitPython is for you to see that first, that we have Python and now we're applying it to something. You will use Python to apply it to all kinds of stuff, but I've given you then, or no, not given, I provided and you worked for that first application so that hopefully you have the comfortability to then try that onto other things, be it a camera, a server, whatever it might be. Oh, and also you need to take that quiz on Canvas about the syllabi and using the on-screen name for Discord. So track down suitable reference resources, look through those ebooks, and then make sure that you have Python, Sublime, and Mu installed on your computer, and make sure that you have a CircuitPython compatible microcontroller ready to go by next week. And that's pretty much it for today. So welcome to BS Meta. Indeed. Thank you guys.